One of those unknowns, of course, is what you just said, the drugs and the vaccine. Because, one of the theories for a cure is hydroxychloroquine. India has just exported it to the United States. Another theory, countries with BCG immunization programs like India are perhaps better equipped to take on the virus. How do you see it? Do we have a theory? There's much talk today of an American company which claims to have got a drug that could combat corona. Are we any close to having a drug or a vaccine? And is there any truth in hydroxychloroquine or indeed BCG vaccine theories?
So let's take those questions one at a time. Let me take a step back before I answer the question, and it will be a long answer. So just be prepared. When you develop a new drug against a virus or any microbe, there are, especially in the context of a pandemic, it really goes through certain phases. The first phase is a drug that can be developed from a previously existing human drug. So this is called drug repurposing. So in other words, the drug is already existing in the human pharmacopoeia. We repurpose it to use it for this virus. Those are the ones that come first, and the reason is that we know that their safety profile is likely to be the best. So there are several drugs in that category, but the two that stand out. One of them is hydroxychloroquine, as you said, and the second one is a drug called remdesivir from Gilead Pharmaceuticals. So let's take those two. We'll come back to those two in a second. So the first category, as I said, is repurposed drugs that have already been in humans. The second set of drugs that will come on are antibodies, not vaccines. These are antibodies that are made to specifically latch on to coronavirus. We know exactly where to latch on to because the viral structure has been solved for the most part, and the structure of the so-called spike protein, the part that attaches itself to cells, has been solved, and the domain, the subpart where it's most likely to work is now known. This will probably be a cocktail of vaccines, cocktail of antibodies, and they're being made right now by several companies. And we actually, Kiran Shaw of Biocon and I are in constant conversation to try and make these available in India under a licensing agreement. So you'll hear more about that in a second through Syngene, Biocon, etc. We are in almost daily conversations to license them and bring them. The trouble with antibodies is that they're much harder to make. It's not like making Tylenol or making penicillin or hydroxychloroquine. You have to produce them in these enormous tanks, almost the size of a swimming pool. And you have to keep them clean and decontaminated and extract out the antibodies. They are very likely to work. And we will see them in human trials probably in June at the earliest, because they take a lot of time to make. The third category is new drugs that we invent from scratch, new molecules. And there are several candidates there. These candidates usually, they attack the virus's capacity to make copies of itself. We should take a step back and say, oh, what is a virus? A virus is a piece of genetic material with a coat, which goes inside cells and then parasitizes the cell's genetic apparatus to make more and more copies of itself. That's what a virus is. So viruses have special genes in them, as well as the cell's genes, that they use to make copies of themselves. So the third category, I'm sorry, I hope everyone's still following with me.
No, it's fascinating. Go ahead.
The third category are new drugs that are made from scratch by screening against specific parts of this virus copying machinery. These take even longer because the first step there is to go through safety studies in humans, the so-called phase 1 or even a phase 0 study, after you finish some animal studies to go through some human studies to ensure that in fact these work, and then phase 2 and phase 3 studies, randomized studies, to look at whether these work or not. The final category, the fourth one, is a vaccine. Vaccines take the longest time. They're, of course, the most effective in the context of a population, but they take a very long time because of several reasons. You have to get the right vaccine, you have to target the right protein, but most importantly, remember, you're giving the vaccine to people who have no disease. So your safety profile for a vaccine has to be extraordinary. So we usually, the fastest that we can generate a vaccine has been on the order of 12, 16, 18 months. And then you have to vaccinate people. That takes another 12 months, let's say, across the world. So you're really looking at a vaccine that is about 18, 20 months away. We are accelerating that at a massive speed, but you're really looking at a vaccine that's really about 20 months away at the latest.